Hey everybody, we are on triangle congruence proofs. This is similar to yesterday's, but this one we're doing ASA and AAS. And in the previous video, we looked at the first three here. I think I have that still. Yep, we did these guys. All right, so kind of the full proofs of those as examples for you. Okay, now here I want to give you guys some hints and some places to start for these proofs. Okay, now you're gonna have to practice kind of writing them out, but I'm gonna give you the idea and kind of where to start. All right, so depending on how you want to do it, I sometimes first start by looking at what I'm trying to prove, like what is my goal, and then go back to the given and see what I have to work with. Okay, so I want to try to prove that EK is congruent to KH. That's my goal, to show that these guys are congruent. Now notice they are both, they're corresponding parts of these two triangles. So sometimes if we want to prove two segments are congruent, it's easier to go back and show that the triangles are congruent and then use CP/CTC to show that the segments are congruent. So just recall that as soon as you show two triangles are congruent, you know that all three sides are congruent to all corresponding three sides, and all three angles correspond and are congruent to the other three angles. So we're going to start by showing these triangles are congruent. All right, now what we have to work with is that we have EF parallel to GH. Okay, now parallel is super important idea. Whenever you see parallel lines, my suggestion will be to look for alternate interior angles. So we actually have two pairs here. We have this guy and this guy, angle F and angle G. And we also, because there's two transversals, we also have another set. We have angle E and angle H. All right, so alternate interior angles is going to give us those two right off the bat, just to kind of make it easier to see. Sometimes it's hard to see with extra lines, but this is basically point F, and this is basically point G right here. And so our alternate interior angles are these guys that we're talking about right here. Okay, now we have another transversal going this way, so that gives us another pair of alternate interiors, which are these two. Okay, so that's kind of the shape that we got going on. Now we can get the other angle here with vertical angles theorem if you want to. You actually don't have to, because we also know that EF is not just parallel to GH, it's also congruent to GH. And so what you have here is an angle side angle congruent to an angle side angle. Okay, so that's pretty much what you need in order to get the triangles are congruent. So this is kind of the flow. Start with the given. Okay, then you want to show that angle F is congruent to angle G, alternate interior angles theorem. Then you want to say that angle E is congruent to angle H, alternate interior angles theorem. Then you want to say that this triangle, GKH, is congruent to this triangle, FKE. And if these two triangles are congruent, then as a bonus you get all the other pieces. Now, before you prove the triangles are congruent, really know this angle, this side, this angle, and this angle are congruent. But as soon as you prove that the triangles are congruent, we use CP/CTC. And CP/CTC means corresponding parts of congruent triangles are congruent. Which parts? All of them. All the corresponding parts are congruent. So these two are congruent. And these two are congruent. We already knew these were congruent. We already knew these were congruent. We already knew these were congruent. We also know these are congruent. All right, so CP/CTC gives us 6 pieces of information. We already had 4 of those pieces of information, but we get the extra 2 as a bonus. So that's how we show that these two are congruent. Okay? All right, let's take a look at number 5. This one's pretty fast. We want to show that VR is congruent to SR. That's our goal. And just like we did in the other one, we're going to start by showing the triangles are congruent. Okay, now what we know is that angle V is congruent to angle S. That's given. We also know that TV is congruent to QS. That's also given. That's pretty easy. So basically we just need to show that angle 1 is congruent to angle 2, which we can do by vertical angles theorem. And then we got angle side. Thank you. I don't know if you can hear that clapping, but there's a presentation going on next door. They just started clapping, and it sounded like they were clapping for me. They probably weren't. Okay, so let's kind of run through the idea. Start with the given. The next step is you're going to say angle 1 is congruent to angle 2, vertical angles theorem. The next step is you're going to say that triangle, there's a few ways to name it, but let's say TRV is congruent to triangle QRS. That's going to be by angle, angle, side. Once you get that those vertical angles, you got angle, angle, side. Okay, now if I prove the triangles are congruent, then I know the corresponding parts of congruent triangles are congruent. So these are corresponding parts, which means they must be congruent. And these are corresponding parts, which means they must be congruent. And these are corresponding parts, which means they must be congruent. Right? So CPCTC gives you 6 pieces of information. Now, a few of those we already had, but we get the rest of them as soon as we prove the triangles are congruent. Okay, so start with the given, then go to the vertical angles, say that they're congruent by vertical angles theorem, then say that the triangles are congruent by angle, angle, side, then use CPCTC to show that VR is congruent to SR. Okay. So in this one, we're trying to prove that YZ is congruent to EZ. And that is going to be super easy. Just kidding. All right, so we're trying to show these two are congruent. Now again, our strategy for doing that is to get congruent triangles first. Okay. Now it's kind of hard to tell which triangles we should use here, but really what it comes down to is where your parallel lines are. Okay, so we know these lines are parallel, and it's a little bit tricky to figure out which pair of angles that you have when you have a transversal here. So I just like to extend my lines, my parallel lines out, just so that I can kind of visualize what's happening here. Okay, so I'm going to spin this, because this is kind of how we're used to looking at this. So here's my 2 parallel lines. Okay, now the alternate interior angle, one pair is right here. Okay, the tricky part about this is the other pair of alternate interior angles that you get from these parallel lines and this transversal actually go outside of our shape. That would be like this full angle, this big obtuse angle, and this big obtuse angle. Okay, so because they go out of the shape, I can't use alternate interior angles to show that this little angle is congruent to this little angle. It doesn't work that way because those actually are alternate interior angles for these 2 parallel lines. They are alternate angles for these 2 lines, but we don't know that those 2 lines are parallel because it hasn't been given yet. Okay, so you got to be kind of picky here about which is which. I'm going to switch gears because I kind of marked that up. So I'm going to get a clean freshie here. Right. Okay, so again, the angles that we have are this guy and this guy. Okay, now don't call that angle E and angle Y because there's multiple angles using E as a vertex. So you'd have to call this something like TEY. It's congruent to CYE. Here's another hack for you though that's pretty cool. If you want to, just number the angles. Call them angle 1 and angle 2. You can do that. It's just a label. You're not adding any information other than just labeling the angle. So now I can say angle 1 is congruent to angle 2 by the alternate interior angles theorem. Okay. We also know Z is the midpoint of CT, which means it's halfway in between C and T. And the midpoint, by definition, divides a segment into 2 congruent segments. So that's nice. Okay. I also know that these 2 are vertical angles. Now I could start talking about these 2 triangles, but notice that I don't have any angles for these 2 triangles. I mean, I could get the vertical ones, I guess, but I don't have these angles. So I'm using the triangles that I have the most information for. That's these 2. Okay, so I'm going to use the vertical angles theorem to show that these guys are congruent. And now I can show that the triangles are congruent by angle, angle, side. Angle, angle, side. Okay. Once the triangles are congruent, all the other parts come along for free, which means that I can show that this part, YZ, is congruent to this part, EZ, because they're corresponding parts of the congruent triangles. Okay. Now, just to kind of make this a little bit simpler, I'm going to cross out all this garbage because I'm not using that stuff. Ignore all that stuff. We're talking about these two triangles, okay? And sometimes there's just extra lines adding there just to kind of like, I don't know, distract you or just make it, make you think a little bit harder or something like that. So really what I have here is these two angles. Now I'm going to name these angles just for ease of labeling. I'm going to label them 3 and 4, okay? So let's run through the whole thing again. Okay, start with the given, of course. Always write the given first. That's your first line. Okay. Your second line, you have some options. It's up to you where you want to go, but we need to start talking about some angles. So what I would say in line 2 is that angle 1 is congruent to angle 2, alternate interior angles theorem. Okay, in the next line, I would say angle 3 is congruent to angle 4, vertical angles theorem. Okay, next I would say triangle EZT is congruent to triangle YZC. I know that because angle, side. So that's the angle, side postulate, angle, side theorem. You just say AAS. So the triangles are congruent, okay? Now if the triangles are congruent, now I get all the other pieces that I didn't have for free. So now I know that this guy is congruent to this guy because they're corresponding parts of congruent triangles. I also know now that this guy is congruent to this guy, which I didn't know before. I also know that this angle is congruent to this angle. But that doesn't matter, right? Who cares about all that? What we really care about is saying that this is congruent to this, and we can say that because the corresponding parts of congruent triangles are congruent. Okay? So that's kind of the deal there. That should help you get going. You're going to write out those proofs, whether it's flow or whether it's 2-column. I think I kind of explained them in a 2-column way, but if you want to put that into a flow proof, that's totally up to you. Okay, hope that helped. I hope you guys having a great day. See you in class tomorrow. Don't forget, quiz tomorrow.